Welcome everyone. Today we're going to get into the territory of tangent, secant, circumference, and arc length. So, tangent is basically a segment or line that intersects a circle in exactly one point. So this right here, I'm looking at my circle right now. Here's an example of a tangent. So this segment or line intersects this circle only at one point at D. So we can say that line segment CD is an example of a tangent. Now for a secant is essentially a line that intersects the circle at 2 points. So here, let me go ahead and use my highlighter. First of all, this right here is a chord because both of its endpoints are on the circle. But if I were to extend this chord, then you have a secant. Okay, so line segment CA is an example of a secant. All right, so now what we're going to do as we're going through the notes, we're going to look at angles of a circle formed by certain things. So the first thing that we're dealing with here are chord angles. So here are my two chords, and you can see that we have 1, 2, 3, 4 angles. Now, before I delve into that, we're going to go ahead and look at this word here, vertex. That's going to play a key role as we go through the notes today. So remember back in semester 1, we talked about how angles are formed. We could have a segment or array like this, and joined by this object is another ray or segment. So I'm drawing two rays here. This is my first and this is my second ray. And these two rays share a common endpoint here. That little dot that you see, that's my vertex. So this is going to be super important for this scenario here. We have the vertex inside the circle. So here's my circle, and the vertex is inside of the circle. Now, if the vertex is inside of the circle, we have a formula to figure out certain things here, okay? So, let's say I want to find angle 1. Remember, the vertex is inside of the circle, and if I want to find angle 1, what I need to do is, since this angle is the left angle, then we look at the adjacent arcs. We look at the left arc and the right arc, and then we're going to use that to figure out, use those two things to figure out our answer, okay? So let's go ahead and write this. If I want to find the measure of angle 1, that's going to equal to the measure arc AB plus the measure arc CD all over 2. Okay, so the measure of angle 1 is equal to the measure arc AB plus the measure arc CD all over 2. Now, because we can figure out the measure of angle 1, right, that means we can also figure out the measure of angle 3, because these two, segments here, they create vertical angles. So angle 1 and angle 3 must be congruent to each other. So I can go ahead and say measure of angle 1 is equal to all that. But at the same time, it's equal to the measure of angle 3 because of vertical angles. Now, let's go ahead and figure out the measure of angle 2. Now, that's the top angle, right? So if I want to find the measure of angle 2, then we look at the top arc and then the bottom arc. We add them up and then divide by 2. So it's the measure arc AC. So let me go ahead and let me go ahead and utilize some room here. Measure of angle 2 is equal to the measure arc AC plus the measure arc BD all over 2. So if the vertex is inside the circle, we add the 2 arcs and then divide by 2. So here's the measure of angle 2. That means that's equal to the measure of angle 4 by, again, vertical angles. Okay? So let's take a look at some examples here. The vertex is inside of the circle, and my goal is to figure out what x is. So here's x, that's the angle. It's the right angle, so that means I need to look at the right arc and the left arc, add them up and divide by 2. So here we go. I write x, the angle, is equal to the 130 plus 84 divide by 2. You're going to get 214 over 2, and therefore x is 107 degrees, and that's your answer for A. For B, we have the vertex inside of the circle, and x is located right here. So if you were to rotate this a little bit, this is the bottom angle, so that means we need to look at the top and the bottom arcs. However, we don't have a number here or there. We only have numbers here and there, okay? So that means if I want to figure this out, we're gonna have to use, some sort of game plan to figure out that, okay? All right, so I have these 2 given arcs here, and they work with these angles. So what I'm going to do is I'm going to call this angle here, sorry, we're going to call that y. Okay, so angle y, right, the measure of angle y is equal to, all right, so that's the, quote, left arc. So I need to look at the left and the right arcs. Sorry, not left arc, that's the left angle, right? This is the left angle. So we're going to look at the left and the right arcs and then add them up, divide by 2. So y is equal to 143 plus 75 all over 2. And you're going to get 218 over 2, which just simplifies to 109. Okay, so we're not finding what y is, right? Our goal is to figure out what x is. So if y is 109, right, we know that this angle here is 109 degrees, then what is this angle, right? I want to figure out this angle in particular. Now, as you can see from the highlighting, this right here, with these 2 angles sharing that same side, we have a linear pair, right? So if this is 109 degrees, then I can do 180 minus 109 to figure out that missing angle. So if y is 109, then x is equal to 71 degrees because we can do 180 minus 109, okay? So that's B. All right, for C, this is where x is located. And let's say that this is the top arc, right? So top, bottom, and this is the angle. Remember, the vertex is inside of the circle here. So if I'm looking at 110, and that's the top angle, 110 is equal to the top plus bottom arcs, divide by 2, and I need to multiply both sides by 2 here. You're going to get 220 equals x plus 97. So x is 123 degrees. Okay, so that's pretty simple for that one. Now, we're going to go ahead and get into this territory, the angles of a circle formed by chord/tangent angles. Now, the vertex is on the circle, right? So here we have my chord, and this is the tangent. And notice that the vertex, is on the circle. We've already talked about this in the previous lesson, right, where you have a circle and the angle is inscribed in the circle, right? The vertex is on the circle itself. So if the vertex is on the circle, then the angle is 1/2 of its intercepted arc. Right? So let's say that this angle here is x, and this arc, the measure of that is 24. So if the angle is 1/2 of its intercepted arc, then x must be 12, right? We talked about this in the previous lesson. With this one, it's the same idea. Let's go ahead and label this angle 5. So I'm going to label this angle 5, and I'm going to label this angle 6. Again, the vertex is on the circle. So if I want to figure out the measure of angle 5, right? The measure of angle 5, it is 1/2 of its intercepted arc. So 1/2 of the measure arc AB. If I want to figure out the measure of angle 6, again, the vertex is on the circle here. The measure of its angle 6 is 1/2 of its intercepted arc. Now I'm saying intercepted because this arc is between the two segments or rays or whatever, right? So this arc is being intercepted. So the measure of angle 6 is 1/2 of the major arc ADB. Okay? So there you go. Now, if I want to figure out the measure of angle QPR, so here's QPR, notice that the vertex is on the circle. So to figure out the measure of angle QPR, that is 1/2 of its intercepted arc. So 1/2 of 148, which is 74 degrees. Okay. For this example, it says find the major arc DEF, right? But here's the thing with this problem. This angle is 64 degrees. Okay? It's not involving this arc whatsoever. So what we need to do is we need to develop a game plan. This angle only intercepts this arc. Okay? So let's go ahead and make a note. The measure of angle FDC is 64 degrees. So what is the measure of this arc? Well, if the angle is 1/2 of its intercepted arc, then the intercepted arc itself is twice the angle. Okay? So I'm going to make a note. The measure arc FD is twice the angle. So that is 128 degrees. So this arc is 128 degrees. So what is this arc? Well, we know a circle is 360 degrees. So I can go ahead and write 360 minus 128. And that's going to give you that blue arc, which is 232 degrees. So this is 232. Okay, so that's your answer. All right. Now flipping to the back side of the notes, we have angles of a circle formed by three scenarios here. 1, tangent and secant. 2, the two tangents. And 3, the two secants. Now, here is our little thing, the keywords that we're going to need to figure out what's going on here. The vertex is outside of the circle. So if I'm looking at this example, our tangent and secant here, notice that the vertex is outside of the circle, right? And we can also say the same thing for these two examples here. The vertex is outside of the circle. Now, if the vertex is outside of the circle, then this is what you need to know. The angle is equal to the big arc minus the small arc over 2. Okay? So again, if the vertex is outside of the circle, then your formula is the angle is equal to the big arc minus the small arc over 2. Now, do not make the mistake and say small arc minus big arc over 2. That's not going to work out, and you're going to get the answer wrong. Okay? So if I'm looking at this example still, again, the vertex is outside of the circle. It is the... So if I write, let's call this angle 1 over here, right? So the measure of angle 1 is equal to the big arc. So that is the measure of arc AD. So the measure arc AD minus the smaller arc over here, which is what? Measure arc BD. And then we're going to write all over 2. Okay? So that's the same idea with these two examples. So we're going to go ahead and look at this problem here. It says find the measure arc CD. So notice that the vertex is outside of the circle. So what I need to do is I need to follow this here. Angle is equal to the big arc minus the small arc over 2. So what's the angle? So this is 56, right? And it's closer to that angle. So that 56 is referring to the angle. This 95 is referring to this arc here. And this, the measure arc CD, is what we're trying to figure out. So here is my angle. So it's the angle, 56, equals the big arc. So let's go ahead and say the measure arc CD minus the smaller arc, which is 95, all over 2. Now notice that this is what I'm trying to figure out, but that 2 is in the denominator, so I need to multiply both sides by 2. So you're going to get 112 equals the measure of arc CD minus 95, and then I can go ahead and solve for the measure arc CD. So I'm going to add both sides by 95, and you're going to get 207 degrees here. Oops, not X, it's the measure arc CD. So the measure of arc CD is 207 degrees. Okay? All right, so next example here. The vertex is located outside of the circle, and we're trying to figure out what the measure of angle L is, right? So the measure of angle L is equal to, again, it's the big arc minus the small arc over 2. So I don't see a number for this big arc here, so I'm going to go ahead and leave this blank. So I'm going to, leave some room. I'm going to put a space after the equal sign here. So blank minus the smaller arc, right? That's 102 all over 2. Now, here's the thing with this example. We actually have a tangent here and a tangent there. They intersect the circle once. So if I know that this is 102 degrees, then what is the measure of this arc? Well, this is a circle, it's 360 degrees, right? So I can do 360 minus what's given, which is 102, right? And that's going to help me figure out this big arc here, which is 258 degrees, right? So this is 258 degrees. So now I have my big minus small over 2. I can go ahead and do the math here. So you get 156 over 2, or 78 degrees. So the measure of angle L is 78 degrees. All right. Here's our next example. Where's the vertex located? The vertex is located outside of the circle. So it's the angle. Notice that 25 belongs to that angle. And then X is this arc. And then 110 is that arc, right? So vertex is outside of the circle. It's the angle equals the big minus the small. Can't say X minus 110. Do not make that mistake, okay? So it's 110 minus X all over 2. So you have 50 equals 110 minus X. And let me go ahead and put 50 plus X equals 110 there. And now I can go ahead and subtract both sides by 50. So X equals, what is that going to give me? 60 degrees, okay? So X is equal to 60 degrees. So those are our problems for problems that deal with the vertex outside of the circle. All right, so here we're going to go ahead and talk about the circumference now. Now the circumference is the distance around the circle. All right, and that's, the words kind of sound familiar if you know what perimeter means. Perimeter just means the distance around a figure. Whenever we refer the perimeter of a circle, whenever we say the perimeter of the circle, we mean circumference. It's the distance around the circle. We're talking about length here. We're talking about inches. We're talking about centimeters. We talk about meters and all that sort of thing, right? So to find the circumference, there's actually two formulas that you need to know. One, we have C, which stands for circumference, is equal to 2 pi r. And the other one is going to be C equals pi d. Now, r is the radius and d is the diameter. Okay? So the diameter is twice the radius, or the radius is 1/2 of the diameter. Let's go ahead and look at these examples here. Number 1 says find the circumference if the diameter is 8. Now, which one do I use? Do I use the first one or the second one? Well, I'm going to use the second one because that deals with the diameter, right? So C equals pi d, and C is equal to pi times, what is the diameter? It's 8. So then your answer is C equals 8 pi. Now I'm leaving my answer, so I'm going to make a note here. I'm going to leave my answer in terms of pi. I don't want to multiply 8 with 3.14. I just want to keep it nice and exact. So C is equal to 8 pi will be the best answer to look at here. Okay, so again, do not multiply by 3.14. That's an approximate. That's not that's not exact. So just leave it in terms of pi. For this other example here, if the circle has a circumference of 24 pi, find the radius. So you can see what we're dealing with here. So which formula do I use? Do I use the first one or do I use the second one? I'm going to go ahead and use the first one here. C equals 2 pi r. Now, notice that the circumference is given, right? The circumference is 24 pi. So I'm going to replace C with 24 pi, which is equal to 2 pi r, right? We're finding the radius. Think about, solving for x here. So r is going to be my little x that I need to solve for. So what do I need to do to get r by itself? Well, in this case, this is 2 pi r, or 2 times pi times r. So since this is multiplication, I can use my inverse operation here. where I divide both sides by 2 pi. So these will go away, and I'm left with r on the right-hand side of the equal sign. Now, on the left-hand side of the equal sign, I can see that the 2 pi's can cancel, and I'm left with 24 over 2, which is just 12. So your radius is 12. This example here is basically working backwards. So instead of finding the circumference, I'm finding something else, which in this case is the radius. All right, so the last thing that we're going to be looking here is arc length. Now, arc length is the portion of the circumference of a given circle, where x represents the arc measure in degrees and r is the radius. So if I look at this example here, it's a circle. We know a circle is 360 degrees, right? No matter how big or small the circle, it's always going to be 360 degrees, okay? But we're going to get into the territory of arc length. Again, that's the portion of the circumference. This does not deal with degrees. We're talking about things like inches, we're talking about things like centimeters, we're talking about meters and all that sort of thing, okay? So if I want to find the arc length, we're going to use this formula. It is L equals x over 360 times 2 pi r. Now L represents the arc length, and again x represents the arc measure, and r is the radius. So we're going to use this generic picture, and we have some given information here. Find the arc length L of the circle if the radius is 4 and blah, 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 right? So our first example, x is 100. So this here is 100 degrees. And remember, if the central angle is 100 degrees, then the arc is also 100 degrees. But we're not dealing with degrees. We're figuring out the arc length, the, portion of the circumference here. So we're going to use this formula. We're going to write L equals 100 over 360 times 2 pi, and the radius is 4. So 2 pi 4. What I can see, based on what I wrote here, I can multiply the 2 and the 4. So L equals 100 over 360 times 8 pi. So what I'm going to do is I'm going to use my calculator here to figure out what the arc length is. And I'm going to tell you what I'm doing right now because I want to leave my answer in a specific way. So I notice I have that 100 over 360. So I can put that into my calculator. I put 100 divided by 360. I'm going to press enter, and I have a decimal. Now, I'm multiplying this by 8. So you're going to press the multiplication button on your calculator and then press 8 and hit enter. Now, notice that we, again, have a decimal. So what I'm going to do is I'm going to convert that decimal into a fraction, a simplified fraction. So I'm going to press math, enter, enter, and you get 20 over 9. But remember, we had that pi symbol in our, setup here. So it's not 20 over 9, it's 20 over 9 pi. And this is the type of answer that I want to see, where the answer is in simplified fraction form and is in terms of pi. Okay, so I'm going to go ahead and make a note. So leave answer in terms of pi and in simplified, and as a simplified fraction. Okay. All right, so let's go ahead and do the same thing for B. So we have L equals 20 over 360 times 2 pi, the radius is still 4. So then I can go ahead and write L equals 20 over 360 times 8 pi. So 20 divided by 360 into my calculator, multiply that by 8, math, enter, enter. So you should get 4 over 9 pi. All right. And then over here for C, L equals 360 over 360 times 2 pi 4. And then this is going to be, okay, well, notice that 360 divided by 360 will cancel each other out. So that's just 1 times 2 pi 4, which is 8 pi. Your answer is just 8 pi. Okay, so we're not dealing with degrees. Our first one is 20 over 9 pi units long. And the other one is 4 over 9 pi units long. And this one is 8 pi. Okay, again, not in degrees, it's just in some sort of unit here. All right.